Alright, hey, so 6B, we're talking about characteristics of rational functions. Characteristics of rational functions. So let's say I'm going to give you a rational function. Let's go f of x equals x minus 1 over x plus 5. We're going to graph this thing and do some analysis along the way. So this learning target really is all about graphing. And to build our graph, we're going to start by identifying our intercepts. So you need both the x and the y. Okay, so your x-intercepts, you're going to find them. Well, if you've got a fraction and you want to make 0, how do you, like, when does a fraction equal 0? When the numerator is 0, okay? So these are the zeros of the numerator post cancellation. In the problem I gave you, you'll notice there's nothing that canceled out, in the numerator and denominator. But, maybe the problem instead was you had like an x minus 4 on the top and bottom. So you'd first cancel those out, and then you'd look at the zeros of the numerator. Yeah, and that would make a hole in the graph. Yep. So what are the zeros of the numerator post cancellation?
1, 0.
1, 0, yeah, 1. That just means you're looking for what values of x make the numerator 0. If you set the numerator equal to 0 and solve, you just get x equals 1. So 1, 0. So yeah, when you get to your assessment, you're thinking, okay, I have to find the x-intercepts. Okay, I've canceled everything out that can be dropped out.
Oh, the asymptotes are on the bottom.
The asymptotes are on the bottom, yep. So now we're looking for the y-intercepts. That's when x is equal to how much? When, yeah. So to find the y-intercepts, when x equals 0, otherwise, I'm saying plug 0 in for x. Plug 0 in for x. See what y is. 0 minus 1 divided by 0 plus 5 equals negative 1/5. Yep, it would be 0, negative 1/5. So your x-intercept was 1, 0. Your y-intercept is 0, negative 1/5. Holes in the graph. Does this graph have any holes? No. Nothing in the numerator cancels with nothing in the denominator. So I'm just going to go, nope. These would be, you're looking for the zeros of the factors that cancel out. Zeros of the factors that cancel out. So this doesn't have any factors that cancel out, so there aren't any holes in the graph. And we got vertical asymptotes. can't spell asymptotes, I will ding you on the assessment.
Asymptote.
I'm just kidding, though. You don't have to spell it right. Just get close.
No. You should put it on there so you get some points.
Extra credit. Put it as extra credits. I just write that.
Asymptotes.
It's just asymptotes.
See, I would get like a 4 on that.
All right, so these are the vertical lines. Vertical lines are in the form. Are they x equals or y equals?
X equals.
X equals. Yeah. And a nice way to remember that is points along a vertical line all share the same x value. So that's why the equation is x equals. So these are going to be x equals equations. And they are the zeros of the denominator post cancellation. So we're looking at x equals -5. Okay. Yep. You're looking up here. Zeros of the denominator. -5. So vertical asymptote. That's in green here. And you have one more thing. One more thing. End behavior. That is just the quotient. The quotient, not the remainder. So, I'm going to give you and your neighbor just a chance. Look back at the original function, and if you I want you to divide x minus 1 by x plus 5. I want to know what is the quotient. See if you and your neighbor can agree. I don't care about the remainder, just what is the quotient. So take a second. You don't have to convince me, convince your neighbor. Show him why. Show, like, write it out. Help him out.
Okay, so, well, if you're just going to make that, because you want to make the first one, so you're going to make the x is equal and what times x by, you want to make, remember how you try to make the first one equal to the x equal to the second x?
Are we just long dividing?
Yes.
Yeah, speak his language, man. Use the terminology. He said, do long division.
Do long division.
So much easier.
No, it's good. Now go through it. So you guys need to go on your paper, get all the way to the remainder. The remainder is not important here, but it's not. But just go through the exercise. Tell me what the quotient is.
How would you put that? X goes into X one time. You just put a
Why is it not 1? What do you mean by why is it not 1?
And then just x plus 5, you're going to minus
the sign. -6.
-6.
Oh, when I do end behavior?
Remainder, -1.
0. I mean 1. Remainder.
Because we're just using it for estimation. You know, like kind of if I said, hey, you know, what is, if I said, what's roughly 20 divided by 7? You know, for the general purpose, you'd say, it's about 3, it's a little less. Because the remainder is pretty insignificant compared to the quotient, especially when x is really big.
So we got 1 remainder -6.
Okay.
But we don't care about the remainder.
All right, so here you go. That's the end behavior. The quotient is 1. Okay, and we could have said here, end behavior. So this is going to be y equals the quotient. So we have y equals 1. I like Diana's question of, well, why? How can you just ignore the remainder, and we'll touch on it some more later. But end behavior is y equals the quotient. So we have y equals 1. Now we're actually ready to sketch the graph.
Aren't these notes different from?
Well, you'll notice the equation we used yesterday was humongous. We had a quartic over a cubic, and it just wasn't, in hindsight, it wasn't a good place to start.
It was badly luck.
So
It's all Lexi's fault, really.
I did say, yeah, I did. You know, my vision there was, I thought, take a really complicated problem, and I would just kind of show you the thought process I would go through to do it. I was kind of thinking, well, if I could show you what the end looks like, then getting you there will be easier. But I had to do so much explaining along the way that I wasn't actually doing what I intended, which was just going through it real fast, showing you what the end looks like, and then kind of taking you in reverse.
I like this problem.
All right, so we got to put some stuff on here. Let's label our intercepts. Do you guys remember what they were?
Yes, our intercepts were 1, 0, and 0, negative 1/5.
Okay, there's 1, 0, and 0, negative 1/5. Okay.
Mr. Lund, have you ever crumpled up a piece of paper so much that it becomes like this?
All right.
Tissue paper?
We had some other stuff.
This isn't like
What else did we find, guys?
We have a vertical asymptote.
Where's that at?
Yes.
Negative 5?
Equals negative 5.
So you're going to go back to negative 5, and we got a dashed line there.
It goes
Straight up and down.
Then we also
Now, our graph will never cross that vertical line. So when you graph this, you're going to have to kind of do two parts. You'll have to do a left part and a right part.
What's that?
That's
have 1.
what the end behavior was. That y equals 1? Is that a horizontal or a vertical line?
It's a horizontal line.
Horizontal line, y equals 1.
Horizontal.
So what is that? Oh, is that another?
Yeah.
Okay.
This is what you call a horizontal asymptote. Now you know how I said you'll never cross the vertical ones?
You'll never cross the horizontal.
It would be easier if you never crossed a horizontal, but in this kind of introduction, your sketches are going to be good enough if you just figure you won't cross a horizontal. It's possible, and I'll show you more later. But I want you to use these dashed lines as guiding lines. So when you make your sketch, you have these guiding lines.
You should put a little.
Well, let's do the right half of this graph first. So to the right of the vertical asymptote, we got to figure out where the graph lives. Now, it could live in one of two places. Okay, it could live in this top section, or it could live in this bottom section.
No, you should just put it.
But it's only going to live in one of them. So which one do you think?
Top.
Why do you say the bottom? We're trying.
Intercepts.
There are points already on the bottom. The graph has to live on the bottom. So here goes our sketch. Your graph looks something.
I thought there was no holes, Mr. Lund. We should put a little asterisk saying that this is not drawn to scale. Some kids might be.
Not to. I don't know why I put a dash.
Yeah.
Not to scale.
Not to scale.
Not to scale.
There you go.
Why isn't it to scale?
Because look at it. It's just not to scale.
All right, now you got to decide the left-hand side. And the left-hand side, so we're going to the left of the vertical asymptote. You're going to have to decide, does it live above or below? So this is the final thing right here. I don't have the function. What was the original function here?
And x minus 1 divided by x plus 5.
Okay.
So
So
it's going to be on the bottom since you wrote on the top.
no,
What are we looking for right
you're just trying to decide. Well, you have two options, okay? You have the orange option. The graph looks like that. Or you have the blue one. You have to decide orange or blue. And it's not both.
actually blue.
Would it be what?
Like opposites.
No, no, it's not. So no, you're not guaranteed that you're gonna have like this one and the opposite one is over there. Nope. So, do you have any thoughts on how we might, Franklin? That was our end behavior, and that blue dashed line is the that was our quotient. And so I guess that was our work right here. Hey guys, what would the quotient be if you had x squared trying to divide into x?
No, just kidding. No. Yes. Is it really half?
0. You're not going to be able to go from x squared to x.
That's what I was thinking.
That in that case, the quotient would be 0. So you'd be looking at y equals 0. Which of the axes is y equals 0?
X.
Sharp. Okay, yeah. So now we have to decide. I do have a shortcut for you here, but I want to know if you have some thoughts on, or if you just want me to tell you what I do, that's fine too. Aubrey? Was the orange at the top or the bottom? Okay.
Because in Algebra 1, when we learned all the different, we learned one that looked like that.
Yeah. Yeah, I think in, what was that? Inverse variation, yeah. 1 over x. That's cool.
I think I remember addition.
Oh yeah, because normally you have geometry in between. We may have touched it a little. All right. Good. It's a good guess. I'm gonna give you problems where it could be sometimes it'll be the top, sometimes it'll be the bottom. What I want you to notice here is, okay, look back at your equation. Okay, if let's say x, if you plugged in an x of negative 5.1. So if you plugged in negative 5.1, if you plugged in this x value right here,
Oh, it's gonna be on.
do you think we'll get a negative result into this guy? So plug in negative 5.1 for x. Tell me if y is negative or positive.
It's gonna be positive. It's gonna be positive. Yeah, I will. Because they're dividing two negatives. It's gonna be positive.
So you guys said the top is negative 6.1 and the bottom is?
Negative 0.1.
And negative divided by negative is? What if you go closer to negative 5, still on its left? Like, so negative 5.01.
It's gonna still be positive.
It'll still be positive.
Positive? Okay. So that's what we're going to use.
Do you have to go above the highest number?
So you think it's gonna be on the top?
That's a really good question. I'm not sure I fully understand what you're saying. He said, do you have to go above the highest number? By highest number, are you talking about negative 5 there?
Yeah. Or you went 5 point. You said you went 5.1. But if you went 4.9?
It would be a negative. Yeah, if you went negative 4.9, it would be a negative, and we already verified that by drawing this here. Because we knew these 2 points are on the graph, so we drew it below. But you're right. You're right. So when you have a vertical asymptote and you're trying to decide, you know, like, as I get close to this asymptote, does it go up or does it go down? Or, you know, you were kind of picking between, I think, blue and orange. Just pick a number on the side of it that you're looking for.
So if it's positive, it's gonna be up, and negative, it's gonna be down.
Yep. And you're gonna pick. You'll do yourself a favor if you pick. The closer you pick your number to this, the more likely it is that you're correct. And I say that because, let's pretend you had a graph that looked. You had an asymptote here and an asymptote here. And let's say you've got this thing going on right here. So let's say this was at like negative 10. Well, if you pick like negative 9 as your test point, it's going to put you up here. And you'll think, oh, it's above. That means I should draw it up here. No. You want to pick like negative 9.9, which should be closer in here, and it'll reveal that it is negative. So pick those test points really close to the vertical asymptotes. So we come back and we're actually done. You have built a graph of this rational function, kind of through analyzing its characteristics. We did intercepts, holes, vertical asymptotes, and end behavior. So those 4 things every time. So let's do another one. If my test point was negative 5.1, and when I plugged that into my function, I got a positive output, which put me on the positive side of the x-axis, so on the upper half. So if you think, well, if I'm on the upper half of the x-axis, I'm thinking I'm going to be above our dashed line there. So let's go one more. We'll go a whole new problem. Let's go y equals x minus 1. Yeah, let's put this in your notes. X minus 1, x plus 5, x minus 8 over, let's have this one have a hole at 1 and a vertical asymptote at 3. Yep. You can kind of make a note here. So what's that going to influence? Intercepts, holes, holes. Okay, so we might as well record that. Hole at x equals 1. No, you don't, because this is for the purpose of this. It's just. Now, it's cool because you really, it would be helpful to have the y-coordinate of the hole. So to get the y-coordinate, you're going to plug 1 in to the stuff that remains. Okay, kind of your post-cancellation. Plug 1 in. Tell me what you get. That'll give you the y-coordinate of the hole. So, why don't you and your neighbor see if you can agree on what the y-coordinate is?
6, 7, negative 56 on the top.
Okay, on the bottom?
Is negative 2. So
23?
23.
23, we okay with that? Okay. So 6 times negative 7 divided by negative 2?
Oh wait, no, it's 41. Just kidding, it's 21.
21? Oh, you said 42. Well, what we did was we took all of the x's that remained, and if you replace them all with 1, so that would be 6. That would be negative 7. So 6 times negative 7 is negative 42. And the bottom would be negative 2. 21. So that's going to give you the y-coordinate of the hole in the graph.
So it's 0,
1, 0, then 21, then 2, so the hole would be out 1, 21.
21. So you go on your graph, you'd go over 1 up 21, and you put an open circle.
And with the top, for the x-intercepts being negative 0, negative 5, 0, 8.
Yes. Oops. So you guys can go ahead of me, do the the intercepts, do the x and the y. You're right, man. Yeah, good job. Negative 40 over negative 3.
40.
Wasn't it? Isn't it negative 40 over negative 3? So, oh, you're saying so 40 thirds?
Yeah.
Okay. Yeah, and if you guys want to do the y-intercept as a decimal, that's fine. So,
What would that be?
40 thirds. 13 point. 13 remainder 1, so 13 and a third. 13.33.
13.33. Repeating.
Okay, so check. We verified where the holes are on the graph. We've got the intercepts.
Now we just need the vertical asymptotes.
Vertical asymptote.
Equations of zeros. So
Are these x equals equations or y equals?
Y
Y equals. Okay, y equals, because they're vertical lines, so they got to be x equals.
they're x equals. Yeah, that's what.
Why do I listen to
So wait, how do you find the vertical asymptote?
So if you go back to your notes, what do you have for vertical asymptote?
It's just three. It's zeros of denominator.
Zeros in the denominator. So look at the denominator. In the denominator, you have x minus 3. So what makes x minus 3? 0? 3. That's where the yep, that will be the vertical asymptote.
X equals 3.
Asymptote spelled ASYMPTOTE. 4 points.
S.
No, asymptote.
And you
I
grab
said,
the capital letters and space.
okay, I didn't spell vertical asymptote. I spelled asymptote. Singular.
All right, end behavior. Okay, you guys can do the division post cancellation. That's fine. You can do it pre or post. Okay, so if you're gonna do polynomial long division, though, you're gonna want the numerator and denominator in standard form. So you don't have any work to do in the denominator if you just work with x minus 3, but you are going to need to divide or multiply out x plus 5 times x minus 8.
X squared minus 3x minus 40.
X squared minus 3x minus 40. Okay. And what are we dividing into that?
X minus 3.
Okay.
I got x negative remainder 40.
Okay, so that's 0.
I got x.
Yeah, I got the same thing as you. So do you care about?
You don't care about the remainder.
Just x. So so your quotient is x. Is that you write that as y equals or?
X equals 1. Right?
Look in your notes. It's y equals. End behavior is y equals x. Okay, y equals the quotient. That's just a line. Don't worry. Don't worry. It'll be a diagonal dashed line, and you're just gonna try to figure out which side of the line it goes on.
Y equals X.
Just a line on a piece of paper.
Okay, so well, you can do this. What time are we out? Please tell me it's 10. Okay.
10.
All right. We got time to finish this.
Tell time.
Okay, so I'm going to go ahead and do the intercepts first.
He just made the digits.
Is it x? X is horizontal, right? So,
It's an x equals line?
well, just like it's x, y.
Yep. X is the horizontal.
So 0, 13.
0, negative 13, or no, 0, 13.33.
Then the vertical asymptote is at 3.
3.
And then the end behavior is that's
That
horizontal asymptote, right?
Yeah, well, okay, now if I graph the line y equals x, what's the slope of that line? It's 1. It's the line that has a slope of 1 that goes through the origin. So if this thing was drawn to scale, right, it's and I can't even draw these.
It's just a diagonal.
It's just your standard 45-degree angle line.
Okay,
Oh,
so
because it has to
when you
be
end
equal
up
to
with
each
that,
Yeah, good. Yeah, that's what you end up now. So you're still going to have to the left and the right of that vertical line. And where was the vertical asymptote?
vertical asymptote
was
3.
that
3. Okay.
You okay, Jack?
Okay. So we're going to do to the left of the vertical asymptote. Now you got two options, guys. To the left of the vertical asymptote, you can either be above the diagonal line or you can be below it. Which one do you think it is?
above?
Above.
Just because there's
Well, you're always going to separate it based on your vertical asymptotes. So you could do the left first or the right. But you guys, is it the yellow or the blue? What'd you say? Yellow? Okay.
2 points.
Yeah, you got the 2 points. So your graph, I'm going to move this so we have a little more space.
Cut. Paste.
that's right.
So our graph in this nice blue color is going to be. Oh, we didn't put the hole in yet. Where's the hole at?
What's what you doing?
121.
121.
I say 127 big cat.
That's like way above that. So it's way up.
So the hole's like right here. So that's 1. It's on to the left of the vertical asymptote.
So
So that's at 1.
Is that another way you can know where the hole is?
What's that?
Where which part you use is where the hole is on the graph. Can you figure it out?
Well, we knew that we got the x-coordinate of the hole in the graph from the stuff that canceled, and the y-coordinate from, well, once it canceled, you plugged it back in. So your graph, guys, ends up looking, yeah, just like that.
Yes.
except that was really bad.
It's like weirdly played. Oh, I see. It starts like.
It's always going to get, the whole point of those dashed lines, the further you go out,
Flatter.
it's going to get closer and closer to that dashed line. Now, the right side, you're going to have to, you got two options. It's either this guy here,
This
It's
part
the
I
yellow
don't
one.
get.
or this, or is it's going to occupy this space in here.
It's the red. It's the red.
It's the red.
Why?
Because there's a
Why do we
point.
have to,
Because there's a point in the red section.
why do we have to draw another line?
Which, like the orange, why did I draw the
You
orange?
always have to use something else.
So yeah, no. Why is there two sets of the graph? Two
He's
sides.
wondering why there's.
So the vertical asymptote, figure it breaks your graph. It breaks it, so you're gonna have to kind of have to piece it together one side at a time.
Oh, I see. Okay.
So the right side, make sure your graph, make sure it passes through this point here.
So do you just get it as close to the asymptotes as possible?
Yeah, and so this bottom one I draw really close, and then it gets farther.
So, oh, heck yeah.
Heck yeah.
So it's just gonna keep getting closer to that dashed line.
I figured this out. I got it. It's fine.
So, hey, that's our introduction video. I really hope that turned out because you guys had great questions. So, yeah, just